Welcome to another invigorating episode of AP Computer Science. Make sure to have your writing implements ready because today's lesson is going to be short. Searching a linear data structure, such as an array, can be as simple and straightforward as checking through every value until you find what you are looking for. A sequential search, otherwise known as a linear search, involves starting at the beginning of the list or sequence, sorted or not, and searching one by one through each item, in the order they exist in the list, until the value is found. This unsophisticated approach is the appropriate for small lists or unordered lists. The order of sequential search is linear. The word binary refers to anything with two possible options or parts. A binary search involves binary decisions are two choices. The underlying idea of a binary search is to divide one's data in half and examine the data at the point in the split. If the data is sorted, it is very easy and efficient to ignore the other half of the list of the data, depending on where the value that is being searched is located. Assuming that a list is already sorted, a target value is searched for by repeating the following steps. Divide the list in half. Examine the value in the middle of the list. Is the target value equal to the value there, or does it come before or after the center value? If the target value comes before or after, then return to the first step to repeat the process with the half list where the target value is located. For example, with a list of 1024 sorted values, we happen to be searching for a target value that is stored in position 492. Using a binary search, the list of 1024 is split in half because the target value is not found in position 512. We proceed to search the first half and discard the values in the second half. Within the sublist from 1 to 512, we do another binary search sequence, split, examine, and binary search again. The speed of binary search comes from the elimination of half of the data set each time. If each arrow below represents one binary search process, then only 10 steps are required to search a list of 1024 numbers. The log base 2 1024 is 10. In the worst case scenario, if the size of the list is doubled to 2048, there's only one more step that is required using the binary search. The efficiency of the binary search is illustrated in the comparison of the number of entries in a list and the number of binary divisions required. The order of binary searches. The binary search algorithm can be coded recursively or non-recursively. Here are some arguments for each method. A non-recursive version requires less memory and fewer steps by avoiding the overhead of making recursion calls. However, the recursive version is somewhat easier to understand and code and is more fun.